So 3M, we're working on lesson 8 today, where we determine the equation from the graph or a description instead of the other way around. So the first thing I'm going to write down is the vertex form of a parabola, because that's the easiest to come up with an equation for. And I am going to insert the numbers for A, H, and K dependent upon my graph. So the first thing that I see is that the vertex has been moved 1 to the right. So if I were to write my vertex, it would be 1, 0. My vertex gives me the values for H and K. So far, I know that my equation is going to look like x minus 1 squared plus k. Plus 0. I do a quick mental check. Does that make sense? Have I moved it 1 to the right and up or down 0? Yes. So you don't have to write that 0. The next thing I check is that I haven't changed my step pattern or changed it upside down. So is it upside down? No. So A is going to be positive. Has the step pattern or the shape changed? So I'm going to do a check for the first 2 points. Normally, I would start at the vertex, go over 1, up 1. Yes. From there, I would normally start at the vertex, go over 2, up 4. Yes. Normal step pattern, my A value is 1. Final answer will be y equals, you could write a 1 or not write a 1. X subtract 1 squared, and you could put plus 0 or not. Second graph is a little bit harder. It's a little bit harder to see where the points fall, so they've given us a couple of hints. So I'm going to write out the equation of a parabola and try and determine my A, H, and K values. First thing I'm going to look for is the vertex. It appears that the vertex is at 0, 0. Well, that makes life easy. So far, I have y equals A, x minus 0 squared. Well, I don't need the brackets then, plus 0. So the only thing I have to figure out is the A value. First of all, I know that A is negative, because it's upside down. I am suspicious that A is a number larger than 1 because it looks to be skinny. So I have to determine what has changed with my step pattern. It appears that it is over 1, down 5. My A value is y equals negative 5x squared. It is possible I've made a mistake. So I'm going to show you an algebraic way to just figure this thing out. Let's get a little space here. Okay. Y equals ax squared. I think my A value is negative 5. But I do know that I could use a point to determine my A value. I like the look, so I'm putting substitute 2, negative 20. I like those numbers into the equation. My 2 is my x value. So I'm going to substitute 2 there. My negative 20 is my y value. Let's check that my A value should in fact be negative 5. 2 squared is 4. If I want to get A by itself, and I have A being multiplied by 4, I get rid of the 4 by dividing both sides by 4. My A value is negative 5. Awesome. For the third example, we're finding an equation when we've been given a description. So I am writing my equation. I have stretched this parabola vertically, factor 4. It does not say upside down, so I'm going to assume my A value is positive. but it has been stretched vertically, so that changes my a value to a 4. I have translated my parabola 3 to the right. That's a horizontal change, and I know it's backwards to what you would think. So it's x subtract 3. It doesn't say anything about moving it up or down, so I assume my k is 0. And I am done. The next one opens downward, so I know my a is negative. I've been given my vertex, so I have my h and k value, and it's congruent to y equals x squared. It means the same shape. It means my a value is 1. So all of the things that I know are going to go into my equation. My a value is negative 1. You could just write negative if you like. My vertex is at 3 and negative 4. That's my h and k value. I have moved my parabola 3 to the right and down 4. X subtract 3 squared subtract 4. The next slide walks us through the same process. We're determining the equation from a graph, and it says to state the transformations that were applied to the graph y equals x squared to obtain the graph below. Well, I see that my parabola has been moved upside down. I see that the vertex has been moved 4 to the right and up 5. And it looks like the step pattern is a normal shape. No compressions or stretches, or just say normal shape. And I want to put all of that information into an equation. So it's upside down, but it's the regular shape. So it would be y equals negative 1. If I have moved it 4 to the right, I need x subtract 4. 5 upwards would be a plus 5, and I have my equation. For this graph, we're going to list in English what's going on here. First of all, I see that it has been moved. The vertex is no longer at 0, 0, but it is 2 to the right and down 2. I see it, but they've also written it just to make sure. I also see that it opens upwards, so A is positive, but it does not follow the normal step pattern. So from the vertex, I go over 1, up a half, I think, but fractions are harder to see. So I'm going to check one more step. From the vertex, my next point would normally be over 2, up 4. And this time, it's over 2, up 2. So all of that step pattern has been halved. My A value is positive because it's upward, but the steps are all a half. It has been compressed, factor 1/2. So for my equation, y equals a minus h squared plus k, my a value is 1/2, and my vertex comes from the h and k values. It would be x subtract 2 for the 2 to the right, and subtract 2 at the end for down 2. Can you work with your table for the next 3 pages and make sure you can do those? There will be another handout available for you if you get finished and need something more to work on.